All right, let's get right into it. For pretty much ever, road safety has played out the exact same way. Something bad happens, a crash, and then we react to it. But what if we could just flip that entire script? What if we could use AI to stop crashes before they even have a chance to happen? Well, that's exactly what we're going to break down right now.
And this slide right here just perfectly captures the whole shift in thinking. Over on the left, you've got the old way, the past. A crash happens, it gets detected, someone files a report, and then, way down the line, maybe some action is taken. It's all after the fact. But look at the right. This is the future. The system sees a risky pattern developing, it calculates the odds of a crash, and then, and this is the game changer, it steps in to stop it.
And that really brings us to the heart of this new safety paradigm. We are talking about a fundamental shift from cleaning up the aftermath to living in a constant state of, well, intelligent anticipation.
So what exactly is predictive road safety? Well, think of it like a system that's always looking just a little bit ahead. And notice that time frame, 30 to 120 seconds. We're not talking about predicting a traffic jam for your commute next Tuesday. This is about spotting a very specific danger that is unfolding right now and giving us just enough of a window to do something about it.
Okay, but how does a system even see that kind of danger? What are its eyes and ears? Well, that takes us to the system's senses, all the different streams of data it pulls in to get the full picture of what's happening on the road. So the system is watching and listening from all these different angles. It's using road cameras, it's feeling what the car is doing through telemetry, things like speed and hard braking, and it's even keeping an eye on the driver's state by looking at things like their eye movement. Then it layers on top of all that data from traffic signals, the weather, you name it. It's a truly complete view. And here is the absolute key insight. A crash almost never happens because of just one single thing. It's usually a dangerous combination of factors that build up over time. A tired driver approaching a tricky intersection, maybe it's starting to rain. The AI is designed to spot that dangerous recipe as all the ingredients are coming together. So we've got all these senses flooding the system with data. But how does it make sense of it all? Let's get into how the AI actually thinks, how it goes from all that raw information to a decision that could literally save someone's life. It all works through this pipeline. You start with the data sources we just talked about. Then feature engineering basically cleans all that data up and pulls out the most important signals. The real magic happens in the GenAI risk engine, which analyzes those signals to figure out what's going on. And finally, the decision engine says, okay, here's what we need to do about it. So why use generative AI specifically? What's the big deal? A traditional AI model might tell you there's, say, an 85% chance of a crash, which is useful, for sure. But GenAI goes a step further. It can actually tell you the story. It doesn't just see the what. It understands and can explain the why. It can reason about the cause of the risk.
And this is a perfect example of what that looks like in practice. The AI doesn't just spit out a number. It gives you this clear, human-readable report. So the risk score is high, 0.81. And why? Because of driver fatigue and unstable speed. So what's the plan? Alert the driver and extend the traffic light. It's not just a prediction, it's an explanation and a recommendation all in one.
Now, this all sounds amazing in theory, right? But what does it actually look like out on the street? So let's jump into a couple of real-world examples of how this system goes from predicting a problem to actively preventing it.
Let's start with a super common one, the rear-end collision at a busy intersection. First, the system detects the telltale signs, like a whole chain of cars slamming on their brakes one after another. Based on that pattern, it predicts that a collision is probably about to happen. And then, the most important part, it acts.
So what can it actually do? Well, it has a whole toolkit of options. It could extend the green light for just a few more seconds to help clear out the intersection. Or it could flash a warning on one of those big overhead signs to tell approaching drivers to slow down. The whole idea is to break that chain of events before that final disastrous link can connect.
Okay, how about another huge problem, sleepy drivers? Here, the system uses what you could call a risk ladder. If it detects a medium risk, the driver is blinking a little too slowly, it might just play a soft alert inside the car. But if that risk gets high, it gets more direct, showing a message saying, hey, you need to take a break. And if things get critical, it can actually intervene, limiting the car's speed and sending an alert to a central monitoring system. Now, this kind of technology is incredibly powerful,
But for people to actually adopt it, they have to trust it. So for this last section, let's talk about that trust, about transparency, and what the future looks like when you scale this up to an entire city.
I mean, just imagine this. The ultimate goal is to have an entire city's traffic grid working together, a system that can predict where crash hotspots are likely to form 15, even 30 minutes in advance, and then automatically reroute traffic or change signal timings to dissolve the danger before it ever fully forms. But, and this is a big but, none of that can happen without trust. That's why a core principle here is that every single action the AI takes has to be auditable. You can see it here. When the system decides to limit a vehicle's speed, it creates a log. It notes its confidence level, 92%, and the exact evidence it used. This is not a black box. Every decision can be opened up, reviewed, and understood. And look, all of this naturally leads to a really important question, probably one that's on your mind right now. With all this monitoring, is this just more surveillance? And the answer, really the main takeaway from all of this, is no. This isn't about surveillance. It's about changing our focus from monitoring people to monitoring the conditions that create danger. The goal is to take surprise out of the equation, that one sudden, unexpected moment that leads to a catastrophe, by using intelligence to see it coming before any human possibly could. So I'll leave you with this final thought. If we can use this kind of technology to anticipate and prevent something as chaotic and random as a car crash, what other surprises in our world, maybe in healthcare or supply chains or even our own daily lives, could we start to remove with this same way of thinking?